As we know, the speed of light is approximately 300,000 kilometers per second. It is the fastest speed at which information can be transferred from one place to another. What do we make of entanglement then, in which information is seemingly transmitted instantaneously? The general attitude in popular science and even in many physicists is to act completely perplexed, to simply shrug and say, quantum mechanics is weird, no one understands quantum mechanics. But what if we choose not to throw the explanation into some black hole of our own creation? What if we just accept what quantum mechanics is telling us? Unlike what we used to think with classical mechanics, objects don't actually have trajectories. They are instead really described by wave functions. It then follows that superposition is not some extra weird thing that sometimes happens. Superposition is the general case. Wave functions are added together and multiplied by complex numbers to form new wave functions and form a Hilbert space. There is a tendency to act as if quantum mechanics only occurred in some separate magisterium of small things, or in particular applications like these levitating magnets. But when it implies that we are nested in a braid that contains an infinity of worlds, some physicists still scramble their papers, duck, and run out the building, muttering slurs like metaphysics or philosophy. But this is physics. All our actions are weighed by a factor of infinity, and we cannot escape. Here are the solutions of the Schrödinger equation for a hydrogen atom. A simplistic explanation is that where you see color is where you are more likely to find the electron. A textbook might say the electron can be anywhere, but many worlds says the electron is everywhere. Even the regions that have no color actually have their due expression. What you see is a useful approximation that describes its probable location and a description of its probable bonding behavior. The different shapes correspond to the different energy levels. Solving the Schrödinger equation for anything above the first element of the periodic table has turned out an elusive endeavor. But in principle, you could construct one of these pretty shapes for a human, and all those points would be real clones, the colored regions containing the greater infinity of configurations. Decoherence doesn't contradict special relativity. Just stop thinking of uniqueness and outcomes. The statistics of what we observe are described by the Born rule. We are all part of the same universal wave function. Again, if you care about the truth, it is counterproductive to think that quantum mechanics only applies to the functioning of this computer or when levitating objects. The collapse postulate suffers from something along those lines. It says that there is pure randomness until an observation is made. This was the traditional interpretation, but it has been losing favor because an observation is arbitrary. Whether we are talking about a measuring instrument or our occipital lobe, these are also made of the same quantum mechanical stuff, so they are part of the machinery. Where do you draw this boundary that collapses a wave function into a single reality? Accepting many worlds solves this issue. Under many worlds, the double-slit experiment is evidence not of collapse into a single reality, but merely of the fact that you find yourself in the reality that you do. Your Hilbert space clones also find themselves where they find themselves. In our universe, we see a photon passing through one slit, and this interacts with another invisible photon traveling through the second slit. In another universe, the photon that we see is invisible to the physicists in that world, while the one that we can't see is the photon the otherworldly physicist detects. There is no magic to your consciousness. It is just a configuration, just like all the other infinite configurations of it. None can directly experience the others from the inside of its own geometry. This is the implication if we are made of the same stuff that is neither wave nor particle, that which is seen in the double-slit experiment. The many worlds also solves Einstein's original concern with quantum mechanics, that it was not deterministic. He would not accept that this world was fundamentally random. Instead, perhaps, only that our eyes were still foggy to the clockwork. In many worlds, there is no fundamental randomness. Everything is a deterministic evolution of the wave function. Just like Einstein had hoped, there wasn't some ocean of amorphous randomness ether at the bottom of reality. It is just complicated clockwork that can be described in principle. The brilliance of Hugh Everett's many worlds insight is that it is very much in the spirit of Einstein's relativity. You are an element of a quantum superposition entangled with this screen. It is no surprise that you are not the observer entangled with his girlfriend instead. But the universal wave function includes that pair too. Now, isn't it rude to assume that state doesn't exist just because you find yourself in a different region? In relativity, the analogous situation would be to assume that everyone ticks at the rate of your reference frame, or that only your present actually exists. Like Stephen Hawking said, what the physics is describing is many worlds, and this is, quote, trivially true. We should not fall into the trap of solipsism, to think that only our own reality exists. Einstein's relativity implies that the past, present, and future are all there, because you are not in the same hypersurface of the present as even the people in the same room. This gives us length to our experience. Quantum mechanics then gives us the girth. Not only is the past, present, and future permanently playing, it is also playing out in an infinite variety of ways.